Now I am explaining about the quadratic equation. It's a very interesting and important topic in secondary, higher secondary and competitive exams. So how to solve the quadratic equation? I am giving you one of the best technique, right? So this is the topic, quadratic equation. In quadratic equation, we have general notation of the quadratic equation is ax square plus bx plus c is equal to 0. Here a is never equal to 0. A should not be 0. If a becomes 0, it reduces to linear equation. Now my question is how to solve such quadratic equation. The way of simplifying the quadratic equations, we have the formula x is equal to minus b plus minus under root b square minus 4ac divided by 2a. So here plus minus means we have the one solution alpha minus b plus under root b square minus 4ac by 2a. Another is beta, this is minus b minus under root b square minus 4ac divided by 2a. These are the two solutions, alpha and beta, of the quadratic equation. So it's a way directly we can simplify any quadratic equation. Whether this is some rational term, irrational term, whatever numbers are there, we put these values here, we get the answer directly. Now, I am giving you the very interesting way to solve the questions. Like, the question is, find the value of this. It is under root 2, under root 2, under root 2 up to infinity. We have another question, under root 6, under root 6, under root 6 up to infinity. Another question, under root 12, under root 12, 12 up to infinity. We want to find the solution of such questions. So generally, what the student do, they assume this is equal to x and they use the technique, they convert this into the quadratic equations and they put the value in alpha and beta, then they will get the answer. I am giving you the technique, within a second you can get the answer of such question. What is that technique? You factorize these numbers into consecutive prime numbers. Two consecutive number, it is 1 into 2. What are the prime factor of this? Two consecutive number is 2 into 3. What's the prime number? This is the factor of this is 3 into 4. Two consecutive numbers, 3 into 4. So what will be the answer? Answer of this question is 2. Directly this is the answer of this question. What is the answer of this question? This is the 3. And what is the answer of this question? It is not 4. Why? Because there is a negative sign. Because of this negative sign, we have to select this number. So this is the answer of this question. This is a very interesting way to solve these questions. But condition is that these numbers, they should be factorized into two consecutive prime factor. If it is not there, so we cannot use this technique. For this technique, otherwise we have to use this one. So this is the best way to solve any question based on the quadratic equation. This is the best applications. So always reduce on a prime factor, you will get the answer directly. And suppose we have this question, this is under root 5, under root 5, under root 5 up to infinity. So here is no numbers, this cannot be split. 5 cannot be split into consecutive numbers, prime numbers. Okay, we cannot have two prime factors of 5. So here we have to use this method. We convert this into the quadratic equations. How is that? Squaring both sides, it becomes x square is equal to 5 plus under root 5 plus under root 5 plus under root 5 up to infinity. So finally it becomes x square is equal to 5 plus x. So therefore final it's the quadratic equation x square minus x minus 5. So here what we have? Here we have a is equal to 1, b is equal to minus 1, c is equal to minus 5. We put all these values in the given expression, we will get the value of alpha and beta. So this is to be applied when there is number is not possible to factorize into the two prime factors. So okay, if it is possible to factorize into two consecutive numbers, so this is the easiest and the fastest way to get the answer of this question. Right? This is the one part of the quadratic. We have the many technique to get the answer of other questions also. So that we can explain you, okay, in later part.